Dear students, now we are going to learn about AC generators. This is a device which has great many applications and it brought revolution in the mankind's life. And you see, it works on the principle of electromagnetic induction. How it works? A coil is placed between the two opposite poles of a horseshoe magnet or any permanent magnet, and nowadays we are even using electromagnets, and then that coil is made to rotate. Due to this, there is change in magnetic flux associated with the coil, and this produces EMF across the two ends of the coil. Now what is done is, the two open ends of the coil are connected to two separate slip rings which are fitted over the axle. The axle is the axis of rotation of the coil. So when the wire is connected to these slip rings, then the EMF can be derived from these slip rings. Coil is rotating, so wire will also be rotating about the surface of slip rings. The coil is connected to these slip rings with the use of carbon brushes, so that the contact is always proper with the slip rings. So the load is finally connected to these slip rings, from which the load can derive the electrical power. Now we make sure that the load is kept outside the magnetic field, because if it is not outside the magnetic field, it cannot draw current, though the charge are accumulated at two different ends. Two different charges are accumulated and EMF is produced. Therefore, due to the Lorentz force, this is restricted, that load should be not within the magnetic field, otherwise current will not flow through the load and no power will be drawn by it. So always load is outside the magnetic field. Now you see, we talk about the construction of AC generator. Usually we have a coil which is wounded over a core magnetic material which we have not shown, which is called armature, and this coil is fixed on the axle, which is also the axis of rotation, and then the coil is made to rotate by some mechanical force applied on it. You see, the mechanical force is these days commonly derived from the heat engines, where we burn the fuel, and that produces rotational motion, and that produces rotation in the coil about the axis of rotation. As the coil is made to rotate, the EMF is generated across the two slip rings, and if we connect load to these 2 point slip rings, the load will derive current from the coil, two ends of the coil. Now initially, at the time of start, let us say, the direction of magnetic field is from my left to right, as shown by this pen, and we assume that this right palm is a coil plane of the coil. Then plane of the coil is held, while the plane of the coil is held perpendicular to the magnetic field, the time taken is 0. So this is the time of start, and then from this point onward the coil starts rotating. So you can divide this time in 4 parts, because while the coil rotates 1/4, the time taken is, say, capital T by 4, where capital T is the time period of rotation, means time required to complete one rotation. So what is one rotation? We start from this point, T is equal to 0, we rotate by 90 degree, 1/4 of the rotation is complete. we rotate by another 90 degree, means in total 180 degree, means half of the rotation is done. And once this is done, we rotate by another 90 degree, 3/4 of the rotation is done. And then finally rotation by another 90 degree, that means in total 300 degree of rotation is completed. The rotation completes, one rotation is completed. So that why in that manner this rotation is done. And due to this, there is always change in magnetic flux associated with the coil. You can very well understand that while the coil is in a position at t is equal to small t is equal to 0, the magnetic flux associated with the coil will be maximum. And so on so forth, there is change in magnetic flux, and due to which the EMF is induced. Well, you see in this case, while t is equal to 0, theta becomes 0, and for that phi becomes maximum equal to BA. Now the induced EMF E is equal to minus n d phi by dt, where what is n? You see a flux associated with each coil we take as B into A cos theta. So this is the magnetic flux associated with each coil, and if there are n number of turns in the coil, then we have total magnetic flux associated with the total coil will be n times B A cos theta, and therefore EMF induced will be n times d phi by dt. D phi is magnetic flux associated with each coil. So we have on differentiation, you see phi is equal to B A cos theta, and B is constant, A is constant, n is already outside, so we have differentiation of d cos omega t by dt, where omega is the angular speed and t is the time, instantaneous time. And when you differentiate, you see when you differentiate it with respect to omega t, you get minus sin omega t, and then omega t is further differentiated with respect to time, and then we get omega. So we get on differentiating, we get EMF induced is equal to minus n BA minus sin omega t into omega. So minus sign cancel each other, and we get n omega AB sin omega t. So this is the total EMF induced across the coil, and so you can see that when t is equal to 0, the EMF induced will be 0. And for different stages we can see that means when t is equal to 0, EMF will be 0, and when t is equal to capital T by 4, then EMF will be maximum, because in that case sin omega t, that is sin 90 degree, is 1. So that means we have maximum value of sin omega t, and for that we have maximum value of EMF. So you can very well use this formula to find when the EMF is maximum or minimum. When the value of sin omega t is maximum, that is 1, EMF induced will be maximum, that is equal to n omega AB. And when the value of sin omega t is minimum, that is minus 1, then EMF will be minimum equal to minus n omega AB. And the value of EMF will be 0 when value of sin omega t is 0. that is when omega t is equal to 0 degree, and this is when t is equal to 0, sin omega t, sin theta is 0, and therefore the EMF induced will be also 0. Now you see the uses of the output of AC generators are so many. We are seeing in our day-to-day life. Whatever function we arrange, we don't have main supply available, then we bank on this output of AC generators. We use it for various applications. Also, you see, as the output is AC, we have the liberty to raise and decrease the voltage of the output as per the requirements of the applications, and it brought so many freedom in our day-to-day life, and it has other applications for industrial purposes. Even we use these things. Multi-story buildings are empowered by this when power cut is there, and so on so forth. That's all for today. Thank you and have a nice day.